Welcome back to our class of software engineering. So today we are going to discuss about why software engineering. So we are saying that we are using software everywhere. We mentioned that our life without software is nothing. So our life is intervened in the software. Everything around us nowadays is having some or other kind of a software. Any electronic device that we use has some software. Even if we were having a broadband in our house, a small router that comes along with it is having a software. Nowadays, you're also having the lights, or you have some kind of a sensors available with the lights, where you say, I will have some kind of a sensor. As soon as I enter, light will turn on. And after some time, if there is no movement, it turns off. There's a sensor, there's a software. So, softwares are intervened in our life. Everywhere we have softwares. So different people are having different kinds of demands. So one needs to hear given listening ear to every person who is having a demands, because they are your customers, and different demands are there, different requirements are there, maybe for a same software. So in that case, you have to make it sure that most of those demands are part of your software. So one needs to understand the problem before building a solution. That's what the bottom line for software is. Understand the problem before building the solution. So you may have a problem, but understand it. Then you provide a solution for it. Okay? So that's why we are saying first identify the requirements. What are the requirements are there for this software? Once you get those things, then you can start building the software. Okay? So first get the requirements, design, and then implement solution. Second thing is there is a change now from a single programmer to large teams. Okay? So you can have programs which are smaller. It's a small program, maybe it's for a single use, or for a single user in that case, or for a group of users which you build and you provide to them. They will use it. So in that case, a single programmer is there. He himself will identify the requirements, do the designing, implement the program, do the testing, do the maintenance, give it to the customers. However, that is a very small program. The program size is large. For large programs, you have larger software teams or software developer teams. So in this case, there will be many people involved. Some will be acting as the requirement engineers who will collect the requirements. Some will act as designers who will design the software. Some will act as a developers or implementers. Some will act as a testers. Some will act as a maintainers. So this team will have various kinds of people, or people having various kinds of roles. So in earlier case, we had a single person having all kinds of roles. So he knows system in and out. Now this is other system which is larger, complex software. So in that case, we have multiple people, multiple roles, and many a times these people may keep on changing also. So in such cases, when you are having complex softwares, sophisticated systems, we should have a design. Okay? So we mentioned we require a designer there. So design is a pivotal activity in such cases. You need to meticulously design the system so that implementation becomes easier. For this design, you need to understand the problem first, get the requirements correct, and then you have design. After that, individual, business, and government rely heavily on software. Nowadays, we are seeing in every, like the first statement and the last statement, you can just correlate. Our lives are intertwined with software. Individuals, that means we as individuals, we are using softwares everywhere. Businesses are obviously using softwares. You just identify any business which is not using software, apart from the ones which are who are just say uh, uh, doing a business uh, which is completely say off the track, will not have software there. Otherwise, you go to chai wala, you go to sabji wala, you go to medical shop, you go to pan wala, they are using softwares. You must have seen the advertisements. Okay, they are maintaining their accounts on the mobile phones. They say last time you must have seen the ad of that pan. That person goes on the pan shop and he says, "Give me some certain things." So he says, "भैया वो last time का तो pending है." So, कितना pending है? तो आपको मैसेज भी किया था इतना इतना pending है आपके पास पूरा दिया हुआ है. So they are using the software. So businesses, whether it's a small businesses, whether are big businesses, all are using software. Government obviously we are seeing the government is relying heavily on softwares. They are converting everything into software. They are scanning all the land records, making the land records available online. You can make applications online. You can get various kinds of certificates online. You can have your government issued certificates in a wallet which is approved by government. It checks it there. We have wallet there. You are having online banking. You are having wallets, Paytm, Google Pay, Phone Pay, Amazon Pay. So all these businesses are heavily relying on software. So we for such kind of businesses we require softwares which are having long duration. So we should build a software which is usable for longer duration. So in such case, software needs to be of high quality and has to be maintainable. Like we mentioned, software will face some kind of a changes. Okay? Change is inevitable. So in that case, we have to make it sure that these changes are adaptable. So in that means the software has to be maintainable. Okay? So three things: we need to understand the problem first before building solution. That means we need to have all the requirements in place. Second, design has to be perfect as far as possible, has to be perfect. Third, software should be having good quality or high quality and is maintainable. Okay. So for all these things, apart from we have mentioned that various kinds of people are involved and many times they are having different roles. Roles keep on changing, people keep on changing. In such cases, you require a mechanism, you require a methodology, you require a system which will make it sure that my software product will be delivered even if people change, even if roles change, even if certain changes are there, my software remains. My software is delivered, my software is developed, delivered, maintained, serviced throughout its life cycle, and my customer is satisfied with my software delivery. So for all these things, we require the software to be engineered. That's what I mentioned. Software is engineered. It's not manufactured. Okay? It's developed or engineered. Okay? So again, here also we are seeing that software in all of its forms and across all of its application domains should be engineered. It is developed. It is engineered. It's not manufactured. Okay? So whatever its form may be, it may be application software, it may be system software, it may be an expert system from AI, it may be a system of system, it may be operating system, maybe a device driver. Whatever the form software has, it has to be engineered. And in that case, we need some kind of a methodology to do those things. Okay? So for that, we require a software engineering discipline. Okay? So because we are going to engineer software, we are saying something called as software engineering. Now let's see what is software engineering. We are defining a software engineering: establishment and use of engineering principles in order to obtain economically software that is reliable and works efficiently on real machines. That's a definition, one definition we are going to provide here for software engineering. So understand from this definition, there are some highlighted colored things you see here. It should have sound engineering principles. Software engineering provides us that establishment and use of sound engineering principles. So there are general engineering principles like it should have a good requirement things, it should have good design things should be there. When you are implementing, at the end we should have a good quality software. So certain attributes are there of software, and there are certain things which are coming from general engineering principles too. So here also we require sound engineering principles to be used for development of a software. Next, the software should be built economically. We want cost effective software. Every business would like to have some kind of a revenue. So business wants maximum profit and customer wants a product with minimum price. Okay? So we as a customer, we know that we keep on comparing whether I'm getting a computer in this shop cheaper or in this shop cheaper. However, with same quality. Right? I may look for i7 10 generation, having a graphics card, whatever graphics card we may be using. So I have some kind of a configuration that I want, and I want with minimum price. Okay. At the same time, the organization, the company would like to deliver certain things, getting maximum profits. They should have some kind of a margin, because there is a chain of people who are involved from the production or the one who is creating a software. Then there are vendors in between, and then there are sellers, and then you have finally a customer. We look for a software, we look for a product which is cheaper for us, which is having less price but high quality. So companies want to build with minimum cost with maximum quality. So to have win-win situation, software engineering would like to provide mechanisms, would like to provide you certain steps, certain phases, certain methodologies by which you can economically develop software. And then the software has to be reliable. We have seen yesterday that there are certain attributes of a software. So in that case, we mentioned software should be reliable. It should be available all the time. It should be reliable. Whenever I'm turning on my system, the system should boot, the system should start. It should not happen that I have to press the button multiple number of times to start my system. No, I don't want that. So system is to be reliable. I know when I press certain things, something should come up. It should come up and then works efficiently on real machines. Software is first developed. We program, we write a program, we execute on some machine, we call it a host machine, and then finally it is sent to some target machine. Like say, I have an operating system. I build the operating system, right, as a software engineer, or you build the operating system, and then one person takes company X laptop, other person takes company X desktop, other person takes company Y's laptop, other person takes company Z's desktop. Now for all these different machines which are having different kinds of configurations, different kinds of hardwares, my operating system should be running on all these devices efficiently, reliably. So that software engineering should provide me. Second is the standard definition provided by IEEE. IEEE is a standard body, you all know. Most of you may be members of IEEE society also. Let's see the definition given by IEEE. It says software engineering is first the application of a systematic, disciplined, quantifiable approach. Right? Three things: systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. So obviously, for these things you may be using some engineering principles too. But first thing is, let there be some system of building a software which follows some kind of a discipline, some kind of a rules and regulations, some kind of a norm should be followed, and all these things should be quantifiable. How much cost it takes, how much human resources will be required, how many number of hours it requires to create a part of a software, how many man hours will be required, how much how many computers will be required, how much bandwidth is required. Quantifiable. I should have some quantifiable things there, and then use it for development, right, operation, and maintenance. That is the application of engineering to software. And then study of approaches as in one. So software engineering involves two things in this case we are saying. First is you do all the you apply engineering principles to build a software, make the software operational, and then you maintain the software. And when you are doing these things, other person may be studying the various approaches for these things. How I can develop a software systematically, what kind of a metrics I can develop. So we will be seeing something called as lines of code, function points, COCOMO model will be used for this purpose. We're going to see some kind of SDLCs, software development life cycles, which will be used for development of a software or operation and maintenance things. So there are different approaches which will be studied for providing this kind of engineering principles for software engineering. Okay, that's definition of software engineering. We have provided more definitions of software engineering. You can go through the document which will be provided to you, in which we'll be seeing more definitions of software engineering, which are provided by various other authors also. So next is software engineering layers are there. Software engineering will encompass multiple things, like we have mentioned in the previous definitions. In the earlier slides, we mentioned some definitions. So where we mentioned that there is development, operation, maintenance, there is system, there is discipline, there are some of the metrics, we require some kind of a cost, some reliability. So here are certain things which will be part of our software engineering as such. Okay? So software engineering encompasses one, a process. So you see there's a process model. There are methods for managing and engineering software. Methods for managing and methods for engineering software or developing a software. And then there are certain tools available for building a software, for developing a software, for implementing software, for doing some kind of a changes, for maintaining software, for rolling out. So these tools are available for that. And you see uh, the foundation for this is quality. We always focus on quality. Okay? So any organization, because an organization is committed to providing us quality software. Okay? So in that case, we expect that any engineering approach should also be part of a quality policy. So every organization nowadays you are seeing, every organization provides a quality policy. They have some vision, mission. Along with that, they also provide you with a quality policy. Okay? So organization commitment to policy always matters. Okay? We always look for a company which has some quality values. Okay? So this foundation that we are mentioning here is a quality focus. Okay? So organization's commitment to policy always matters, and that will foster a continuous process improvement culture in the organization. Okay? So we are seeing various management things for that. Like we have ISO is there. ISO will be used. So many organizations says we are ISO certified. For software engineering, we have something called as sigma levels are there, or we have something called as CMM models are there which will be used. So we look for at what CMM level the organization is, at what sigma level the organization is, what is the ISO is being followed by organization. So there is a quality focus the organization has. Software engineering approaches must also have some kind of a quality focus, which is also part of a organization's quality policy. Second is the process model. So this layer is another foundation as such. You can see the process model, which is defining a framework with activities for effective delivery of software engineering technology. The software will be delivered through this process model. Okay? To be developed using this process model. So that we can say is our SDLC. Okay? Which we'll have as a SDLC. Okay? So it establishes the context where products like model, data, report, and forms will be produced as output of this process. Okay, milestones will be established, and the layer below it is the quality. Quality will be ensured, and changes if they are coming up will be managed. So that will be made sure by this process model, and the process that will be used for development of the software. Okay. Next, we'll be having some kind of methods. Methods are nothing but how to's. How are we going to build the software? How are we going to modify the changes, adopt the changes? How we'll make it sure that this quality policy is implemented? How to make it sure that the government norms are also included in the included while building the software? Because always we say the software has to be usable. Okay. Generally, ethical hacking is allowed, but non-ethical hacking we don't support. Okay, so that's the way we say when we are building a software, we want to make it sure it's a secure, because there are many people who will be trying to have other ways. So how to secure software? Okay, so my software has to be having security also. So how to's will be provided in the methods. So in that case, not only these things, apart from that, as when you're building a software using some process model, how to communicate, how to collect requirements, how to perform requirement analysis, how to design, how to model the given software, how to solve the given problem, what kind of programming to be used, or how to program, uh, how to test, how to support. So all these how to's will be answered in the methods, and then there will be tools, maybe manual tools, or manual tools in this case, the humans will be humans themselves will do certain things to test certain things or to do certain things. Apart from that, you may have some semi-automated tools available which will be supporting the below two layers, these methods and processes. So if you see, we are starting with the quality focus as a bottom. On top of that, we have process model, which will be focusing, which will be taking care of the qualities. Apart from on top of that, we have methods which will be used to answer how to's, okay, how to build a software. So in that case, all questions of will be answered, and then we'll have some kind of a tools, semi-automated tools. So you can say these tools will be integration tools, or there are reusable components are available. You just use those reusable components, and and use those reusable components for providing or building the software as an integration mechanism. So that way we can have software being built. So that's generally called as software engineering layers. Next we'll see is, let me change the slide. Next we have process, activity, action, and task. Okay? We are talking of software engineering as a process. So software engineering as a process will consist of these three things. Software engineering consists of four things: process, activity, action, and task. Okay? Within a process, we'll have three things: activities, actions, and tasks. Let's see one by one the definitions of these. So a process, as we're defining here, is a collection of activities, actions, and tasks. It's a collection of these three things that are performed when some work product is to be created. That's the process. We'll have multiple activities, actions, and tasks. Okay. Now this, when we are talking of the process, the first thing that comes is activity. Now in the activity, we are defining activity as it strives to achieve a broad objective. Okay. So activity is for broad objective, and it is applied regardless of the application domain, size of the project, complexity of the effort, or degree of rigor with which software engineering is to be applied. So activities may be any as such. In that case, you can have communication activities, you can have design activities, you can have testing activities. For all these activities, there is some kind of a broad objective. Like when you say, I want to build, I want to collect requirements. So it's a broad activity. So within which there will be multiple things inside as such. Okay, like there will be some actions, there will be some task. So if you see, process is process consists of these three things. So process is a bigger part, biggest part. Then bigger part is activity. Then big is action, and smallest is your task. Okay? Task is the smallest activity. So here we're trying to achieve broader objective, and these activities we are going to see something called as framework activities and option activities. This will be applicable to all application domains, irrespective of size of project, complexity of efforts, degree of rigor, degree of human resources required for with which software engineering is applied. Okay? That's activities which will be common. Okay? It's generally called as framework activities. Then second is action. It encompasses a set of tasks that produce a major work product. So action will consist of, say in case of communication, we mentioned communication. If it's a major activity, uh, then in that case, after communicating with the stakeholders, we'll get the requirements. Once you get the requirements, based on the requirements, you create a design. So based on requirement software requirement specification document is a major product. Once you go for design activities, okay, You do some design activities, then the action will produce a design document. Maybe an architectural design will be available, maybe component design is available. So I will have a specific work product. If I do implementation activity, my code will be ready, right? So this action is going to provide me a major work product. And then say a task, activities, action, and a task focuses on small but well defined objective. uh, Activities are broad objective and tasks are well defined small objective. Like when you say I want to do some requirement, so major activities, communication with the stakeholders for collecting requirements, based on which I have created the SRS. Now once my software requirement specific document is ready, I go for a task. So say in that case, I talked with one stakeholder for one specific requirement and got a detailed information for that requirement. Okay. So here's it's a well defined objective is there for that functionality. What all functions or what all things are required in that function. Okay. So if we say addition is there, so addition of which number? Is it the case that we want to perform addition of only integers, or will there be floating points also? So, so in that case, I'm making it sure that I'm taking the real requirements from a customer, and in that case, what I'm getting is a tangible outcome. Tangible means I can see. Though software is intangible, tangible in the case I am getting an executable for that part, so I can execute addition program. If I'm building a calculator software, one component of it is a smallest task is to write an addition program. So my addition program is running. That's tangible. That means given two numbers, my program is adding these two numbers. That's my task will be performed. Okay. So these are three. These are the things: process, activities, actions, and tasks, which will be performed, which will be part of our things. Okay. Now let's see software process. What is a software process? Okay. Generally, when we say what a process, talk about a process may be a rigid one as such. It has to be done in this way. Like in the case of manufacturing, if you see, it's a rigid process. You cannot do changes when the production is happening, when the manufacturing of something is happening. Like say, manufacturing of a soap. It's a rigid process. I have to make it sure that every product that comes out is having this kind of a weight. Obviously, there may be some kind of a tolerance, but when I'm saying I'm getting this kind of a soap, only that soap is coming with that weight, and we'll have a rigid process for that creation of that product as such. However, when we talk for a software process, it is not a rigid. Okay? It is not a rigid prescription for how to build computer software. So for softwares, the process is not rigid. It is adaptable. Adaptable. It will adapt the changes. It itself will adapt to the changes. Okay. Software process will keep on changing. Not only software will change, but software process itself may change. Okay. So that's why we're saying it's not a rigid case. Second is, so that's what I'm saying, it's not. It is an adaptable approach that enables the software team to pick and choose the appropriate set of work actions and tasks. Okay. So I may choose. I may first identify that which tasks are to be done sequentially, which tasks can be done parallelly. Which can be done parallelly, I can give to multiple developers. Which needs to be done sequentially, I can give to one or two users, or separately also I may provide. But I have some kind of a flexibility here. Flexibility is provided in the software development. Okay. So the intent of this software process is to deliver software in a timely manner. We mentioned that a business has some quality focus. Business requires to develop a product in minimum cost. So as time increases, cost also increases. Okay? And we know that there is there is a principle which says that as you allocate more time for a task, the task will adjust itself to fit to the given time zone. So say a task can be done in 10 minutes. If Allocate time is 10 minutes, we will done in 10 minutes. However, if you say now we are giving 20 minutes for the task, what you see is that the task expands itself to fit for 20 minutes. So there may be multiple things in that case. You know how software industries functions. We say there are something about deadlines, and when deadline comes up, you see that the software engineers or those who are developers, they say, okay, deadline is coming up, deadline is coming up. We have go live, we have go live. They're working harder. Why? Haven't you got earlier? There may be certain issues, there may be certain things, but the software process, if it is not followed, we will see the 11th hour rush. To avoid that things, or to avoid that kind of say hasty things which will not deliver a product of good quality, we say we should follow software process. And if it is followed, the software will be delivered in time with sufficient quality. Anything that is done hastily, obviously there will be some quality appropriations will be there. Quality will be compromised because we are doing something hastily. Then in that case, the customer will say there's a lot of things which are not functioning. What kind of software provided to me? Do these changes, do these changes. So to avoid those kind of things, we want to provide quality, because if quality is not provided, customers are not satisfied, users are not satisfied. Okay, so that's why many times we will see something called as beta programs. So what are beta programs? They're basically softwares which is not stable one. Even for operating systems, you will see there are stable versions, there are unstable versions, okay? Or there are beta versions. These beta versions are those which are given to some specific users. Use it, test it as per your requirements, as per your say quality attributes, and then give a feedback to us that what kind of changes are need to be performed in this software, okay? So that the quality is achieved, the required quality is achieved for that customer or for that user. So the intent of this software is to make it sure that software is delivered timely at required time. Then we have provided sufficient quality which satisfies the sponsors or users of the software. That is the intent of software process. So this subject that we are studying is entirely for this one purpose, that we want to deliver a software which is having some kind of a quality, which is delivered on time with minimum cost, making it sure that the available resources are utilized optimally, and then the customer is satisfied. A customer is given a software which is usable, which is as per the quality requirements for us, for them, which is secure, which is reliable. So the good software quality attributes are being followed. So let's go ahead now. We'll see something called as a process framework. So we mentioned that there are some activities. So process consists of activities, actions, and tasks. Now first thing is we'll talk of process framework, within which we'll have activities also, we'll have actions also, and we'll have tasks too. So process framework establishes the foundation for a complete software engineering process. That's the process framework. We'll see more detailed things about it, because just by seeing that process framework establishes foundation and which is sufficient for so as a tool, as a foundation for software development, is not just sufficient. Okay? We need to say that there are certain more things also involved in that, and without activities we cannot define software process. Okay? So we'll see that things in the next slides that are coming up. So this framework identifies a small number of, we say 5 to 6 framework activities applicable to all software projects. That's why we say there will be some activities, broad objectives are there, or broad activities are there, which are applicable to all software projects, and there are some specific which we call them as umbrella activities. Okay, so it also encompasses a set of umbrella activities applicable across the entire software projects. Okay, so framework activities are there, and there are some umbrella activities. Now let's see what are these activities. So there are 5 framework activities, starting from communication, then we have planning, modeling, construction, and deployment. So these things we know in some or other manner as such. Like we say, requirement analysis, then design, implementation, testing, and deployment. Okay? So same thing is here also. Only thing is we are trying to say fit into software process in that case. Now, the framework activities first is communication. We are seeing. So communication is with multiple parties. First thing is communication has to be with the customers. Who is my customer? So customer is my stakeholder. So it's not always the case that a customer is the only stakeholder. Stakeholders are also those who are supporting your company, who are sponsors to your company, who are sponsoring your product. Those people are also considered as they are considered as uh, stakeholders. Okay, so communication has to be done with the stakeholders. So communicate and collaborate with the customers and other stakeholders of the organization. You may have third parties, you may have some suppliers, you may have some service providers, okay, for a software also. You may be using some technology which is provided to you by some kind of a vendor. You may be using some operating system which may be a proprietary one for which you require so that party may also be a stakeholder. So there are different stakeholders. So communicate with these stakeholders for different purposes to collect the requirements from customers, to inform the stakeholders that these are the requirements, this is a software which we want to build. Shall we go for it? There will be stakeholders who will be sanctioning some amount, giving you some amount. There will be some person who will be saying, tell me what is the profit out of the software if we build the software. So there are various stakeholders are there. So the intent here is to understand stakeholders' objective for the project and to gather requirements. Okay? So from the customer, you just gather requirements, but from other stakeholders, you need to tell them, okay, this is a project that is coming up. Should we go for it? This is the cost. This is the profit. This is the margin. Okay? In worst case scenarios, what is the profit margin? In best case scenarios, what is the profit margin? Whether we have a customer base for this or not. It may be the case that there are certain products which are built for customers. It may be the case that companies are building certain products which they will float for selling. Okay, like mobile phones are there. For mobile phones, they collect the requirements from the market as such, okay? And then they identify what is the customer base for this mobile softwares as such, or mobiles devices in that case. Okay? So where there will be multiple softwares also available. Then you have some gaming softwares are there. When it's to identify what all different kinds of users will be available for my games. So you build the game, keeping in mind that I have some kind of a customer base, I have some kind of a students, I have some kind of a people who are going to use these kind of things. So then accordingly you can have communication and build the software. Second is planning. Once you communicate, after completing the communication with the customer stakeholders, plan the project. Okay? A software project is a complicated journey. Okay? It's a journey. So whenever you start a journey, so if I want to go from Pune to Mumbai, and if I don't know, how to go as such, if I'm not taking the say a bus or train, which will just drop me, to Bombay or Mumbai as such. In that case, I don't have to think anything. However, if I want to take my own car and go to Bombay, it's my first time. So what I will do, I'll first go on the map, check how from my source to my destination in Mumbai. So from Pune to Mumbai, what is the road map? Which road is to be taken? What are the places where the toll plaza may be there? Which expressway is there? Which way is the best way for me to go? So I create a map. I create a map for my journey from Pune to Mumbai. So I follow the map. Getting? So I build a map and then I follow the map. Similarly, here also, when we talk of a planning provides me a map. So planning activity creates a map, and a map is called as a software project plan. So here is a plan. I have various activities enlisted. Okay, various activities are enlisted, and for each activity, I identify how much time this activity will take. So starting from some date to some end date. So I have started and ended for an activity, or that action, or that task, and then what are the resources required for this? Human resources, non-human resources. So I identified these things and placed on certain say map as such. So I have created a map, I created a plan which will be followed. by software engineers as such, okay, or others in that case. So planning will provide me a software, provide a map which will be called as a software project plan, which will define the software engineering work, okay, how to go from start to end. So you are starting with scratch and you are delivering a product. Okay? So starting from Pune, reaching to Mumbai. Then you have modeling. A model helps to define a problem and to build solutions. So when you say I'm going to go from Pune to Bombay, you have a map, you have a plan, but have you modeled? Have you modeled that how much petrol will be required, how much at what speed I should be driving, can I drive for all this 4 hours or 3 hours, what kind of traffic will be present. So accordingly, I have to model. So I'll create multiple models in that case. With this speed, with this car, with this vehicle, this will take this much amount of time. If I want to go by two-wheeler, then with two-wheeler, with this route, or whether I can go to this, to take this route or not take this route, how long I can drive. So we have these different models. Bicycle, going from Pune to Mumbai with bicycle, going from Pune to Mumbai with a motorized vehicle, two-wheeler, and going from Pune to Mumbai with a car. I create multiple models for my journey. Similarly, here also to build this software project using my project plan, I need to build a solution. So I need to build a model. So I know the problem. So for the problem, I build a solution. I build a model. So model is nothing like we say. Uh, just to give a simple definition of model, everybody knows that there is something called as a Taj Mahal model. Okay? So when people go to Taj Mahal, they visit Agra, and so from there they bring a small model of Taj Mahal. Okay? So they say this is how Taj Mahal looks like. Okay? So that's a model. A software engineer creates models to better understand the software requirements and design that will achieve those requirements. Okay? So model will be developed using designs. Okay? So to just give an example, what we say model of some certain things. So when you are building a house, you can build a model for that. So first we have a blueprint. So on paper, first you get the requirements, and on the paper you draw those things. So if you go for purchasing these flats, they show you the plan, floor plan. They show you floor plan. Right? That's their design. Okay? Now that's a design, but you may not be understanding anything from the design as such. Okay? So they will create you a model flat is ready, sample flat is ready. So in that case, they are creating a sample flat to you, which may be actual in that case, but that may be a costlier affair. So to avoid that, they can provide you a small model, which can be used, from which you can understand. Okay, this house will look like this. Okay? Like we say a map on a paper. It's scaled down version. It's a model of the actual map as such. Okay? Then there are construction. So in the construction, we do actual coding and testing of the software project. Okay? And then after construction, we have something called as deployment. Once your software is tested, after coding, then we deploy. The software is delivered to the customer for evaluation and feedback. Okay, so that's where I deliver the software, and my customer is going to evaluate this software. He will test it from his end. Even though as a developer I did the testing, I may have to provide, because my testing is because I know certain things on my end. However, the customer has his own requirements, and he has given the requirements according to his check. So for our requirements, we are done thoroughly. When it's given to the customer, he also uses it on his system, in his environment, and there he tests and then gives a feedback. If everything is running nice, he says, okay, software is of required quality. We're happy with it. Now, if it is not, then he comes back. There are the errors. There are the changes that are required. Then again, these changes has to be included in my software, and then again do the coding. So I may do some kind of a say more requirement analysis may be required for the changes. I mean to identify, if I include this change, what other things are going to get affected. Then if I require to do some changes in the design, what changes are required in the software, code, and then accordingly do the testing, and then again deliver. So this cycle may continue. That's my framework activities. Okay, so 5 framework activities that we have seen. Okay. Then we have something called as umbrella activities. There are around 4 plus 4, 8 umbrella activities which are present for. So earlier things that we have seen are used for developing a software, and these activities are not used as such, but this will oversee. Okay? This will supervise that whether this software is being built as per the project plan. So for which I would have software project tracking and control. So I have a plan, I build a plan, but whether my software development team is following the plan or not, for which I have an activity called as software project tracking. To keep on tracking, after end of say 1 month, this milestone should have been achieved. This communication should have been finished. This design should have been ready. This model must have been ready. This code, part of a code, must have been ready. Maybe called as a proof of concept earlier. Should have been ready. Is it ready or not? That will be checked by software project tracking and control activity. So these are the activities which are called as umbrella activities, which will be performed on top of or along with as a part of a software engineering process only. Okay? So framework activities and umbrella activities. We'll see one by one. Okay. So after software project tracking and control, next that is activity that is performed is a risk management. So we know that there are various kinds of risks that will be coming up. We'll subsequently see that there may be some kind of technological risk, there may be management risk, there may be risk from because of changes, there may be risk coming from markets. Okay, like suddenly you may see that this product is no more usable, or there is no customer base for this product. So that's the risk. So you may be in the development phase only. Okay? And it may happen that 50% of the product is ready, and you get a customer review or you get a market review that now this software is no more required. That's the risk. Management may see that because of certain situations, like we are seeing in the case of COVID like situations, many software projects were halted. They were not continued. They were suspended. Now that's a risk. This risk has caused because of the market conditions, because customer base are not ready to accept now, or customers are saying that okay, now our users are not able to use it or will not be able to use it. Then why to get this software? Just scrap it out, because there may be some reasons for them also. It may be the case that because of this certain market situations, you don't have the required budgets available. No capital is available for this product, this software. You just will suspend those things. So there are many risks which will be associated with the software development. So one needs to assess this risk and to identify what will be the outcome of this risk. If it comes up, how to deal with this risk, whether we can mitigate the risk, whether we can manage the risk, whether we can avoid the risk. So for all these things, we need to identify the risk, do the risk management. We also need to identify if this risk comes up, how it's going to affect the quality of the product. So for this, risk management activities will be performed. Then software quality assurance, because when we are developing a software in the process, when the software is being developed as such, in those activities like we mentioned, the communication, planning, modeling, construction, and deployment, there are some quality attributes which are not involved in these framework activities, which may be additionally present. Okay, so one needs to define these quality assurance attributes separately, okay? And make it sure that for this, for including these things, uh, uh, including these quality attributes or quality assurance activities need to be added additionally. Okay? So these are umbrella activities that will be covered in the umbrella activity. So software quality assurance activity will be performed additionally in the software process. Then there are technical reviews will be performed, and the technical reviews, they are going to assess the software engineering work products as such. You say my milestone has reached. So once the milestone is reached, that milestone, that work product, which may be an output of that activity or that action, will be assessed by a separate team. Okay. So say software requirement specification document is ready. Now there'll be a technical team which will review this SRS document. Will identify, is there something in this document which should have been there, like there may be some kind of non-functional requirements for performance requirements or some quality attributes which should have been present or not included in that case. Do we need to include those things? When a customer has given some kind of requirements and we have noted them down, is it the case that for some requirement there should have been something which is not included, or there is some requirement which is obvious but which is not given explicitly? Should we ask the customer to clarify whether you are considering that this is implicit or should be explicit? So these kind of things will be performed in the technical reviews. Then measurement, because we mentioned that when we are building a software, and in the definition also we mentioned that we need to have a software which has some measurable outcomes. Okay, we said uh, even when we say the action is there or the activity is there, we had something called as measurable outcome. Okay? Even in the case of defining a software, we mentioned that we are developing something which is economical. Okay? That means there is a cost involved in it. Okay? So in all these cases, we are looking for some kind of a measures. Okay? So we need to define the certain measures, certain metrics should be defined, and we should collect, defines and collects process, product and product measures. So in this activity, we define some measures for processes. We define process metrics for projects. What are the cost estimates in terms of rupees, in terms of work hours? Product measures. What is the efficiency required? What should be the accuracy of the product when the product starts functioning? How many users can use it simultaneously? If you're building a server, how many multiple threads, how many servers can be served concurrently or simultaneously? So those are the different measures, metrics are there which should be uh, provided to the team, so that the so that they will assist the team in delivering the software that will meet meet the stakeholders or the customers requirements or their needs. Okay, so these are all again used with the uh, with our framework activities. Then you have software configuration management activities, because we mentioned that many softwares are built, they are component based. So you just take different components off the shelf that are available, integrate them together, the software is ready. However, there are many which are custom built. So in both cases, you need to configure it for certain things. Okay? Configure it for certain things. Now say when I want to install say Ubuntu on Intel based machine, I may have some kind of configuration there. When I want to use the same Ubuntu on AMD based machine, I may have different kind of configuration there. So software itself should be able to configure. Apart from that, as and when the change comes, as and when the change comes, there is a lot of management configuration management required, because this change will lead to changes in the requirements. So changes coming for some kind of a requirement. It needs to be configured in the design. It needs to be configured from the design to the implementation in the code. Configure it there, and after that you need to configure it for testing also. And then this entire change has to be integrated in the software. You should not look that the change is separately being seen. Now it is part of the software itself. It is configured inside. So we require software configuration management activities to manage these changes throughout the life cycle of the software process. Then we have something called as reusability management. We mentioned that we have off-the-shelf components available. We want to have component-based development. We want to have reusable softwares. We cannot spend the spend every time for same kind of activities. Okay, that's why we say custom build is there. What is happening in custom build is based on the requirements of a user, you are changing some functionalities. Okay? All functionalities are available, but based on that user, you are providing those specific functionalities. Like say when you go for a cloud based system, you get a box there. Okay, you get a box as per your requirements, so they just configure it for you, make it reusable for you. Okay? It's not that every time they are going to give you, they are going to create different kinds of machines for you. They just configure it for you, make it so that it functions for you. So and same applies for software. When you write a code, that code remains reusable. It can be reused again, reused again, reused again. That's where the reusable management has to be taken care of. Okay, so all the software components, make it sure that they are reusable. So they should be having some kind of a reusability, because that will reduce the cost, subsequent cost, when a similar kind of product is to be developed. Because like in say banking systems are there, so say SBI will be using a software. Now SBI may be having some requirements which Bank of India may not have. Okay? So in that case, a financial software is ready. So whatever is not required by Bank of India, you just remove those aspects, and whatever is required for SBI, you provide those aspects to them. Right? So accordingly, you make sure that you have reusable components. Your reusable, reconfigurable, and manageable components are there. And last in this is work product preparation and production activity. So in this activity, uh, uh, this what are the work products are there, such as models, documents, logs, forms, and lists. They will be created, they'll be prepared, and they'll be produced. Okay, so this activity makes it sure that when you say I am reaching some kind of a milestone, okay, and at that milestone I should have this product ready. Okay? Like so we mentioned that requirement phase is in the requirement analysis phase or requirement gathering phase. We collected the requirements. Now after collection of requirements, you need to prepare a document. Okay? So you need to prepare a document. That means software requirement specification document should be ready. Now, when this is my work product, okay, which is the outcome of an activity which is performed, communication activity is performed, and based on communication activity, now my work product is ready. So to prepare these things, we have this activity called as work product preparation and production. Prepare the SRS document, produce it, correct it, and give it to the customer, give it to the developer. Both parties are given. So these are the umbrella activities. So umbrella activities occur throughout the software process and focus primarily on project management, tracking, and control. So umbrella activities are for this purpose: for tracking purposes, tracking the project, managing the project, and controlling various framework activities of the project. Okay. So then we can say that the framework activities will be complemented by umbrella activities. Okay. So framework activities are 5: communication, planning, modeling, construction, and deployment. And umbrella activities which are complementary to the framework activities are 8: software product tracking and control, risk management, software quality assurance, technical reviews, measurement, software configuration management, reusability management, work product preparation, and production. So that's all for the day. So we have seen today certain things about software engineering. Why software engineering is required? Because there are multiple things involved in it, multiple people, multiple parties. It's not a job of a single person now. There are multiple people involved. Okay? So we have a lot of people involved, lot of activities involved. We have various users present there. So we saw why software engineering is required. What are the various aspects of it? That we need to understand the requirements, we need to understand the problem, and design the problem, then do the development of a product as per the quality requirements, and maintenance activities are there. We have seen two definitions. One is the IEEE definition. Other the definition we mentioned that it's a application of engineering principles, okay, to develop software, a cost-effective software with also having the quality. Then we have seen the various layers of software engineering with a focus on quality. So quality is the foundation based on which we have process models, methods used for developing the process, developing the product, which answers how to's, and then there are semi-automated tools which will be used. Then we have seen processes, activities, actions, and tasks which are part of the software engineering. And then we have defined these different things. We have defined the software process, which consists of basically two things: framework activities and umbrella activities. We have seen 5 framework activities and then around 8 umbrella activities. We mentioned that, or we understand that these umbrella activities are complementary activities to the framework activities. That's all for the today. We'll meet again in the next class. Thank you very much. Bye bye. Good day.